Okay, Marc?
Okay. Thank you, Brad. It's not catching me. Is that better? Yes. Okay. So basically, in my experience, before I became an analyst, I had many years doing finite element analysis, and typically we would do analysis and the results were really forgotten about. Never really reused for the investments that we made. That was in the defense industry. And I also observed, I did a lot of work with automotive companies. Very often the same thing is done. Simulation is performed and test is performed at great expense. And after the programs are over, nothing is necessary, they're not referred back to, they're not looked at in very collective, adaptive ways, at least not formally, maybe informally they are. And what I'm saying is there's a lot to be done that way, if I were to net it down, is to use simulation for adaptive learning in more of a community fashion and creating the infrastructure for that. Per Brad's point, I don't know exactly how we're going to do it, but I have some sense of some of the technologies that could be helpful. So let me just very, very briefly look at some of the trends here. I'm old enough now and willing to admit that I started in this world before FEA when we were using matrix methods. How many of you remember the structural book by Przemysław? Come on, raise your hand. Do any of you? Oh, few of you remember that book. That was a precursor to finite element analysis. Finite element analysis actually didn't even have respect among mathematicians until they equated it to the Galerkin methods. It was almost accidental that these matrix methods did have mathematical formalism underpinning them. From FEA, we went to computer-aided engineering and mechanical design automation, as solids modeling and finite element analysis came together. Today, of course, we talk a lot about virtual prototyping and we talk about analyzing complex systems, etc. And this is all well and good about getting high-fidelity models, getting them quickly. But what's the real strategic value of simulation is to have a knowledge base, a collective knowledge base that we're continuously growing and we're learning from. And I just don't see that we're really getting that infrastructure in place. And I would submit the real value of simulation is not the answers it gives us. It's more about the questions that we should be asking after each simulation that we perform. A book I recently read, actually I missed his last name, was this book, Fatal Numbers, that we're all groping for numbers. We all want numbers. And it's not really about the numbers. We should never trust the numbers. We should always be asking questions. And I love this quote: "The illusory certainty of numbers has become a threat to the survival of sound judgment, the genuine capacity for good intuition." This is the spirit with which we should do simulation. And I left his last name off. It's Anzenberger. He's a German poet, essayist, and philosopher. So what should we really be doing? Number one is we want to define the objectives of a simulation. And to the point that Jack Ring raised, is what is really the scope? What's the business question that we want to answer? We want to systematize collective experience. And this is part of the infrastructure that we really need to develop to leverage simulation strategically, define the models systemically. And we've had a number of presentations here about that. Okay, and also be able to validate and document the model that indeed, is it going to give us the objectives? Are we looking correctly at our idealization that the model must necessarily entail? And to what extent can we control errors of discretization? And then finally, simulate and evaluate models. And then basically document our findings and the lessons learned. But most important, what are the new questions raised? And it needs to be done in a community, that these activities are going on and being shared all of the time. That when I do a simulation, I'm taking a look, even from step 2, at systematized collective experience of other simulations. So in a sense, we're synthetically learning. After all, everything we do in life is based on some type of mental model where we've gone through a simulation, even if it's crossing the street. We have a mental model, we're going to look for that walk sign, and we're going to look to the left and the right, and we're going to cross the street. But when we actually do it, we discover perhaps that that road where we were crossing the street, cars may make very sharp right turns, and they don't necessarily look. So the next time you cross that road, you're going to look for cars coming from the right as well as the walk sign. Very simple example of adaptive learning. Now, in terms of this, what we call infrastructure for new product development or modern new product developments is a very high-level logical architecture of how systems engineering tools come together with system test data analysis software, design tools, including software, hardware, etc. We're not really there for that, but the idea is basically while we're doing the simulation, it becomes a knowledge base, a knowledge generation tool that interacts with all of these other activities that we're involved with for new product development. And I was trying to see if I could do this in record time. Some of the technologies that I think we need to involve in order to create this type of knowledge-based or say automated knowledge generation environment through simulation or collaborative capability is number one, an infrastructure, say a community infrastructure. A good metaphor for this is Waze. How many of you use Waze for monitoring traffic? Well, more of you use Waze than used Przemysłowski's matrix methods. But that sense of community, the ability, an infrastructure that's conducive for searching and and sharing. Another is genetic algorithms. When I was at Santa Fe Institute, they had a nice library there. I went into the library and I found a fascinating book, two fascinating books, and one of them happened to be on systems engineering. So I picked it up, and the idea that not only could this be done by community, this can be automated in the sense that you can run multiple simulations just like genetics, build in variability to the models. Some models are very unfit, other models are extremely fit. say, run 1,000 simulations, automated perhaps. You have certain fitness criteria, and then say take the top 20 out of 1,000 simulations, or the top 100, whatever, and then basically create variants of those. Run those genetic algorithms again. They gave examples in the book of a robot picking up cans in a parking lot, where they use these genetic algorithms, and from studying these algorithms, that the answer that it finally converged to, there were insights as to the most efficient path the robot took that seemed counterintuitive. But then, from studying it, they gained strategically valuable knowledge. So, it might be years from now, but why can't we use these same types of techniques for designing complex systems that we live with from day to day? Other important tools are what I would call intelligent search, semantic search, some type of related also to business intelligence and analytics. I'm not sure how it all goes together, but I think these are the types of things that need to be done. One other point that struck a chord with me was a comment Steve Levine made, which people have talked for years, where he had mentioned where a simulation will be a guide to a designer. And everyone's talked about design engineers picking up on simulation. Never really happened. It's not going to happen until simulation is talking the designer language. Not the idea that, okay, here's a model of a fastener, and let's see if it's going to break, and you have to take a look at the von Mises stress. No, when it interacts with the designer and saying, this bend radius is too small, you have to make it bigger, it could be no smaller than such and such, that's when you're going to see designers using simulation, and whether those types of rules are developed systemically in a community or automatically through algorithms such as genetic algorithms, that's when, that's what I see, though, as a worthy goal as to where we should move the technology.
Thank you, Marc.